Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is game of subsets, and it is a hard level problem. So like this particular problem was very interesting, and like the thing was I was getting unnecessary TLEs since the morning. That is why I'm like recording this video a bit late, and I was able to think of the logic very quickly, but it took me a lot of time to implement it just because of the way I was writing. I was getting TLEs for no reason. So my logic was correct, but like the way I was writing was incorrect. So finally I got the accepted verdict, and I'm going to share you what can be one of the ways to solve this particular problem. So it says that like we have been given some values, right? We have been given an array of size n, right? Now we can select a subset from this particular array. Now we should select the subset in such a way such that the product of all the values in the subset is it can be represented as the product of one or more distinct prime numbers. So I'm going to explain you what it means in a while, and what we have to do is we have to just find the number of good subsets in the array modulo 10 is power 9 plus 7, right? So this is our problem. Now let us take some example. So for the first test case, the answer is 6, and we are going to discuss how it can be 6. So you can see we have to select some subset. So the subset will have some values a1, a2, a3 up to ax, let's say, and the product of all these values a1 into a2 into a3 up to ax should be representable as a product of some distinct prime numbers. So the distinct prime numbers can be 2, 3, 5, 7, right? So let's say 3 into 2, 6 can be one of those products. 2 into 5, 10 can be one of those products. 7 into 3, 21 can be one of those products, and so on, right? So in this particular case, you would see we have 2. So 2 is itself a prime number, so it can be represented like this. The second value can be 3, and the third value can be the subset 2 comma 3, because their product will be 6, and 6 can be represented as a product of two prime numbers 2 and 3, right? So these are the three subsets. Now if I add 1 to all of them, 1 3 1 2 3, you would find 3 more combinations, so the total answer is 6, right? Now a very interesting thing about this problem is that the value of array of I is less than equals to 30, right? So this makes a problem specific to a particular domain. Whenever we see these type of constraints, first of all, we'll have to see that if we want to represent the product as a product of some distinct prime numbers, what are all the prime numbers that are less than equals to 30, right? Why? Because if the array of I is itself less than equals to 30, then the primes that for which we are taking the product should also be less than equals to 30, right? So all the prime numbers less than equals to 30 are starting from 2, then 3 and 5, and so on up to the last prime number is 29, I guess. And these are a total of 10 values. So there are 10 primes between 2 to 30, right? So first of all, what we are going to do is we are going to discuss a case. Let's say we are going to assume that 1 is not present in the array, right? We're just going to consider all the other values other than 1, and later I'll show you how we can use this one to improve our answer, right? So first of all, let us just ignore 1, and let us say that we don't have the value 1 in our array. Now this particular problem can be solved with DP and bit masking. So we can create an array of size DP size n 1024, right? So this would be the dimensions of our DP array. Now DP of ij will denote that I am at the ith index, and j will be the mask. Denoting which are the primes that I have taken. Denoting primes that I have currently taken, right? So this these are the two values that DP of ij will denote. So I will be the current index that I am currently at in the input array, and j will be the mask that will denote that I have taken these particular primes. So for example, let us consider the first few primes. So the first few primes are 2, 3, 5 and 7, right? So this is the 0th bit, this is the first bit, and this is the second bit, this is the third bit, right? So if the value of the mask is like this, right? So the value of the mask is 0, 1, 1, 0. It means I have taken the primes 3 and 5 till now. Right, I have taken the primes 3 and 5 till now. This is what they are representing. If I have the value 1, 1, 1, 1, it means I have taken the primes 2, 3, 5 and 7 till now. Right. So since there are 10, since there are like 10 primes, so we will need 10 positions. That is why I have taken the value of mask to be 1024, because 2 raised to the power 10 is 1024. Right. So this is what our DP array is going to indicate. Now, since each of those elements or each of the elements in the product should be distinct primes, right? So, for example, if I have some value like 1, 1, 0, 1, 0, right? So this is the value of my mask. So this was representing 3, 2, 3, 5 and 7, right? Since I have already taken 3, I cannot again take 3 in the product, right? So this is my first observation, but I can still take 2 and 5. So for each of those elements in the array, if I want to find whether I can take the current element or not, we'll have to find, like for example, now the next element is 10, right? So I'll have to factorize it, right? So 10 can be represented as 5 into 2. So these are the two prime numbers that it can be represented as. The current mask was 1010 and the value 10 has a mask 0101, right? If I take the AND of both of these values, I'll get 0000. Taking AND represents that these two values have nothing in common. Only if they have nothing in common, then only I can take the current value. Why? Because if I have already taken a particular bit or a particular prime number and the same prime number is also present in the current value, then I cannot take it, since I have to take distinct primes. So for example, if 7 was here, then the bitwise value would be 1000 and the current mask was 1010. And the current value, mask of the current value that I am going to take is 1000. So their bitwise AND will be 1000. And since this value is greater than 0, that means these two values have something in common. If they have something in common, I would not want to take the current element. Why? Because I cannot take it, because 7 as a distinct prime in the product has already been considered. I cannot consider it again, right? So what I essentially have to do is to check whether I can take a current value or not. I'll have to do the bitwise AND of the current mask, which is representing what are all the values that I have taken till now, and the bitwise value representing which are all the factors in my current element. So for example, 10 was there, it has the factors 2 and 5. So I just take this bitwise value 0 and 01, which will represent at 2 and 5 are the factors of 10. Right. So if I include this particular 10, then a multiple of 2 and 5 will be considered. And since I have considered 2 and 5 now, I cannot use it again. So the final or the next mask would be, so dp of I, if I take the current value, dp of ij will depend on dp of I minus 1. And since I have taken the current value, so j was the initial mask and the current mask is 0, 1, 0, 1. So this is how my dp value will depend on the previous value. If so, this is not XOR, this should be OR, right? So this should be bitwise OR, because since I have taken both of those values, I'll have to do the OR operation, and this will represent that if these were the values, that this value is taken, now this value is also taken, this one was already taken, and now this value is already taken. So this will be my new mask. So here it has to be bitwise OR, right? So this is how my value is going to depend on the previous value. Now if I decide I do not want to take it, or if I cannot take it, right, there can be two possibilities, that I cannot take it or I do not want to take it. If I cannot take it at all, then it will directly depend on dp of I minus 1 and j will remain as it is. If there is a case where I can take it but I don't want to take it, I am just considering a case where I am able to take this value but I am not willing to take this value right now, then it will be added into this particular value dp of I minus 1 and j will remain as it is, because we are not taking the current value, so the mask will not change, right? So this is how our dp states are going to depend on each other, right? So like the next question is, how do we calculate the value of these masks, right, for each array of I? So we are going to pre-compute these particular value, and also I wanted to share one more thing with you. There will also be some values which we cannot take at all, right? It does not depend on the value of the current mask. Why? For example, values such as 4, right? It is itself a product of two prime numbers, right? And the prime numbers is also same. So I cannot take this value at all, right? So you will have to like think of it separately, and whenever you see such a value, you cannot take it and you just have to move forward, right? I'm going to show you in the code how I implemented this particular feature. and I'm going to show you how I take care of this particular statement. I just wanted to inform you beforehand that these are the values that cannot be taken. So since 4 cannot be taken, 8 can also not be taken, right? All the values which have multiple occurrences of the same prime cannot be taken at all, right? So this is the part where I've explained how are the DP states depending on each other and how are we going to do this particular operations. Now the next thing is how are we going to pre-compute all the values since the bits are from 2 to less than equal to 30. These are the array elements. I can pre-compute the mask for all of these elements beforehand, right? So for pre-computing the mask, I'm just going to find. So for example, my current value is val. So I can just find the prime factors of this particular value and just set those corresponding bits to 1, right? That will be my mask of my current value. So this was all about it. Now considering the last part where the value of array of I is equals to 1, right? Now how do we deal with this particular situation? So like you know that if you take 1, it does not change the product. So if the initial product was product, then even if you multiply it by 1, it will still be equal to product, right? So for example, I have taken a subset. I have taken some subsets 2, 3 and 2, 3. These are the subsets that were being formed in the original array. Now I have some ones, right? So what I can do is I can choose this particular one and attach it with this and this and this, all of 3 of them, right? Or the other thing that I can do is I can choose this particular one and attach it with this, right? Like this. The other thing I can do is I can choose this particular one and attach it with them, right? Again, I'll choose these two ones, and then I'll choose these 2 ones to attach in front of them or anywhere in between. The product or the overall product will not change, right? So how many ways will I actually have to use these number of ones and attach to my already known subsets? So it will be equal to 2 raised to the power n, because for each of the ones I can decide whether I can take it or not. So n is the value of the number of ones. So let me just write it as count. So 2 raised to the power count will be the number of ways I can attach these ones. So if there are 3 ones, the number of ways is 2 raised to the power 3. If there was only one, then the value would be 2 raised to the power 1, that is 2, right? So if I have calculated the value of number of subsets ignoring 1, then I'll just multiply that value with 2 raised to the power count into the number of ways I've calculated, right? So this would be my final answer including 1, right? So let me just quickly summarize what I just said. So for this particular question, since the constraint was very small, we decided to go on approach with DP. Now, since like the value of array of I is less than equals to 30, we observe that there are only 10 primes. So what we can just do is, since we can only take each prime only once, so we decided to create a mask which will represent what are all the primes that I have taken. There are 10 primes, so I have to take the value of the mask as 2 raised to the power 10, and that would be equal to 1024. DP of ij will represent that I am currently at the ith index and j is my mask, where the j mask is denoting the primes that I have taken till now, right? So if the ith bit is set, I have taken the ith prime. So 2 will be the 0th prime, 3 will be the first prime, and 5 will be the second prime, and so on. This is how it goes. Now at each position, what I can do is I'll check whether I can take the current value or not. So for example, if the current mask was 1010 and my current value is 10, so my current value 10, if I find the factors and find its mask, it will be equals to 0101, right? So if I do the bitwise AND of all these values, and I get a value 0, that means there are no values that are common in the current mask and the mask that I have obtained from the current array element, right? So if there are no values common, that means I can take the current value. Otherwise, if there are some values common, that means there was a factor which was already included in my product, and if I include the current element, that would again be included in my product. So I definitely don't want them, since I want all the prime factors to be distinct, right? So once I have done this, I have made sure that it can be included in my answer. So my answer will depend, DP of ij will depend of DP of I minus 1, and the mask will change to j, that was the original mask, and the new mask that I have obtained from the current element, I'll do the bitwise OR of both of these values, right? This is the case when I consider the current value, consider taking the current value, and I may not also consider I may like ignore the current value as well. So it will be equals to DP of I minus 1 and j, right? So I'll add both of these values where I do not consider the current value and I consider the current value. What if I cannot take the current value at all? In this particular case, DP of ij would be DP of I minus 1 comma j, right? So it is depending on the previous value. Now once I have done this, I'll do this for all the things. One more important thing, that the mask for each of those values, you will have to pre-compute it. You cannot compute it inside the loops. The next thing is what happens. Initially, we ignored all the ones, and we thought that we will calculate the answer for all the values other than ones. Now, what we have done is we have counted the number of ones in our initial array, and we know that if we choose any number of ones and multiply it to my current number of sets, the product will not change, right? So if I multiply 2 by 1 or 2 by 1 and 1, the product will still remain 2. So I can choose any number of ones from here and add it to my subsets. So what I can do is, if count is the number of ones in my input array, the number of ways I can choose a one from here is 2 raised to the power count. So I'll multiply it by the number of ways that I found, the number of ways, or the number of ways I can form the subsets excluding one, right? So I'll just multiply both of these values and I'll form my final answer. So this would be the solution of today's problem of the day. Now let us have a look at the code. So what I've done is I have created a mod value 10 to the power 9 plus 7, and also I've created a dp vector outside, so it is a global array. The reason is, like, when I was creating it inside, I was getting segmentation fault, and that is because like the values or the arrays that you create inside a function has smaller range and the global arrays has a larger range. So I was able to create it outside, but I was not able to create it inside. So now what I do is I just create a mod value and I just create a map called bits. So it will denote that 2 is at the 0th bit, 3 is at the first bit, 5 is at the second bit, 7 is the third bit, and so on. Like, this is what this particular map is representing. Now I create a vector called mask. So I go through all the values from 2 to less than 31 and I set the current mask as 0 and boolean value as okay as 1. So this is representing whether the current value can be taken at all or not, right? And I'm initializing the value with I. So I'm just running a loop till square root of value. So this is just normal finding the prime factors, right? So while value of j mod j is equal to 0, I'll just find the position of the current divisor j, right, of the current prime divisor. So once I get this position, I just check whether that particular position has already been taken or not, right? If it has been taken, that means this particular value is 1. Right? If that particular bit is set, that means I cannot take the current value, and I'll set OK as false, and I'll just break out from here. Otherwise, what I just do it, I just set that current bit as 1. I'm just taking the OR of this particular value, and I divide the value of j by that particular divisor. So you will observe that this will work in case where there are, for example, in case of 4, in case of 8, or in case of 9. What happens is, for example, 4 was there and 2 is a divisor. So you just set the first position as set bit from here. Like, initially all the bits were 0, so this condition would not have been executed. But now since that particular bit is set, the 0th bit is set, once again value is divided by 2. So 4 was divided by 2. Now the value of the value stored inside this particular variable is 2. Again 2 is divisible by 2, so it enters the loop again. Now it sees that the 0th bit is set, so that means I cannot take this value at all, and I mark OK as false and just break out. So if OK is also false here, I just break out of the statement. Now, since there might be a case when there is a prime divisor like 5. So for example, you will never reach 5 if you go up to root 5, right? So in that particular case, what I'll just do is I'll just find the position of that particular value, and I'll just check whether that particular bit has been set or not. If it has been already set, I just mark OK as false. Otherwise, I set the mask as setting that particular bit, right? I just set that particular bit in my mask. So if it is not okay, then I'll set my mask as 0. Otherwise, I'll set my mask as current mask, right? So now what I do is I just set dp of 0 0 as 0. Why? Because if I'm at the 0th position for the dp array, I'm taking 1 based indexing, right? If I'm at the 0th position and I'm not taken any element, that means I do not consider it as a good subset. Why? Because I have to take at least 1 element. And for all the other values of the mask, I just set it as 1. So dp of 0 I would be 1. Right, this is 0 just because if the mask is 0, that means I have not even taken a single element, and in that case I cannot form my answer. In all the other cases, I'll be able to form my answer. So I initialize my value of count with 0. So this will store the number of ones, and I just traverse to the array. I'm starting from 1 to n plus 1. Now since the array input element, the input array was 0 based indexing, that is why I have to check I minus 1 here. If the I minus 1 element is equals to 1, I increment the value of my count. Now I just go through all the masks from 0 to 1024, and what I just do it, I just find the current value as array of I minus 1. If the value is equals to 1, then I just ignore the current element and I set dp of I and current mask is equals to dp of I minus 1 and the same current mask, right? And I just continue. Now I just initialize my OK variable with 1 and I initialize my variable final mask. So if there exists a mask value, that means the mask value is not equal to 0. When was the mask value 0? When it was not possible to take the current element. So if the mask value is 0, only then I will check this certain conditions. Otherwise, I just set OK as false, right? If the mask value is 0, I check whether there are some common bits in the current mask and the mask of the array element that I am trying to take, right? If there exists some common elements, then OK will be false. Otherwise, the final mask will be the bitwise OR of both of these values, right? So if OK is true, that means I can take the current element and I'll have two values. So the first value is when I take the current element, so I'll have to do dp of I minus 1 and final mask. Otherwise, if I cannot take the current element, I'll still do dp of I minus 1, but I'm going to pass the current mask, right? So I'm not going to change the mask and I'm just going to pass it as it is. So dp of I in current mask is equal to x plus y, like the summation I get from both of those values. And if I cannot take the value, then dp of I in current mask will be directly equal to dp of I minus 1 current mask. So, right, so this is the part that I've done. Now at the end, this is my binary exponentiation function. There is nothing special in it. It's just standard binary exponentiation. You can also find it on the internet. This is a standard code. I'm going to explain you what I'm trying to do with this. So I'm creating a variable ways. So this will store the number of ways I can choose those ones. So as I've already explained you, I have stored the number of ones in my count variable. So I just do 2 raised to the power count and like modding it with this particular mod value, right? So once I get this ways in my final answer, what I can just do is I can return my answer value. So I just directly returned it here. I initially meant to return answer, right? So like both of those is correct since I'm doing the same thing, dp of n0 multiplied by ways. So I can also write answer here, right? So ways is the number of ways I can choose to take the ones. So I just multiplied dp of n0, n is the last position and 0 means that I have not taken any bits till now. So starting from the last position and I have not taken any bits, this is the value that will be storing my final answer, and multiplied by ways and taking the mod with this particular value. So this would be the final solution for today's problem of the day, game of subsets. Let me just try to run this particular code and show you. And like this was a very interesting problem, and you will see that it passes all the test cases, right? So this would be the final solution. Now also I made a couple of wrong submissions in the morning, and let me just show you why I made those wrong submissions and what is the reason of those wrong submissions. So you would see that this part now I have pre-computed it separately, but initially what I was doing is I was like writing inside the for loops where I am calculating the divisors and I'm finding the current mask, right? So this was giving me TLE, right? So this is wrong. You have to pre-compute this, right? So now there is one more thing that I wanted to show you, that just because I was setting all these values as 0, although it is not required, it is adding some constant extra time to my code, and hence this particular code was not working. I was setting all the values of dp of ij to 0. It is not required, but I was still setting it. And when I removed this particular part, it got accepted. Otherwise, the whole code is the same, right? So the reason to show you this particular thing is just because you guys can know like what are all the things that you have to avoid in such questions, right? So I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video. And don't forget to subscribe to this channel. It's always free of cost, and you can always unsubscribe if you don't find the videos interesting later. So like I see a lot of people who watch these videos haven't subscribed yet. So if you're one of them, please do consider subscribing. Share this channel with your friends. Until the next video drops, keep coding, stay safe, bye bye.